CERN Hadron Collider. The Large Hadron Collider of CERN switches on at the highest ever power level to look for dark matter. The detector is set to run at its highest energies yet. The Large Hadron Collider has been turned back July 5th and is set to smash particles together at never before seen energy levels. The Large Hadron Collider, LHC, is the world's largest and most powerful particle accelerator, located at CERN near Geneva, Switzerland, and nearly 17 miles long, a 27-kilometer loop, was fired up after spending 4 years offline for upgrades. With these fixes complete, scientists want to use the gigantic accelerator to smash protons together at record-breaking energies of up to 13.6 trillion electron volts TeV, an energy level that should up the odds of the accelerator producing particles not yet observed by science. The upgrades to the accelerator's particle beams have done more than spike their energy range. An increased level of compactness makes the beams denser with particles, will increase the probability of a collision so much that the accelerator is expected to capture more particles interactions in its third run than it did in its previous two combined. During the two previous stints, running from 2009 to 13 and 2015 to 18, the Atom Smasher shored up physicists' understanding of how the basic building blocks of matter interact, called the Standard Model, and led to the discovery of the long-predicted Higgs boson, the elusive particle which gives all matter its mass. But in spite of the accelerator's experiments, which produced 3,000 scientific papers on many minor discoveries and tantalizing hints of deeper physics, scientists have yet to find conclusive evidence of new particles or brand new physics. After this upgrade, they're hoping that will change. Quote, "We will measure the strengths of the Higgs boson interactions with matter and force particles to unprecedented precision, and we will further our searches for Higgs boson decay to dark matter particles, as well as searches for additional Higgs bosons," end quote. Andreas Hooker, the spokesperson for the LHC's ATLAS collaboration, an international project that includes physicists, engineers, technicians, students, and support staff, said in the statement. Inside the LHC's 17-mile-long underground ring, protons zip around at near light speed before slamming into each other, and the result? New and sometimes exotic particles are formed. The faster those protons go, the more energy they have, and the more energy they have, the more massive the particles they can produce by smashing together. Atom smashers like LHC detect possible new particles by looking for telltale decay products, as the heavier particles are generally short-lived and immediately break down into lighter particles. One of the LHC's goals is to further scrutinize the Standard Model, the mathematical framework physicists use to describe all of the known fundamental particles in the universe and the forces through which they interact. Though the model has been around in its final form since the mid-1970s, physicists are far from satisfied with it and are constantly looking for new ways to test it, and if they're lucky, discover new physics that will make it fail. This is because the model, despite being the most comprehensive and accurate one so far, has enormous gaps, making it totally incapable of explaining where the force of gravity comes from, what dark matter is made up of, and why there is so much more matter than antimatter in the universe. While physicists want to use the upgraded accelerator to probe the rules of the Standard Model and learn more about the Higgs boson, upgrades to the LHC's four main detectors also leave it well positioned to search for physics beyond what is already known. The LHC's main detectors, ATLAS and CMS, have been upgraded to collect more than double the data they did before in their new task for looking for particles that can persist across two collisions. And the LHC-B detector, which now collects 10 times more data than it used to, will search for breaks in the fundamental symmetries of the universe and for explanations why the cosmos has more matter than antimatter. Meanwhile, the ALICE detector will be put to work studying collisions of high energy ions, of which there will be 50-fold increase in those recorded compared to prior runs. Upon smashing together, the ions, atomic nuclei given electrical charge by the removal of electrons from their orbital shells, produce a primordial subatomic soup called quark-gluon plasma, a state of matter which only exists during the first microsecond after the Big Bang. In addition to these research efforts, a slew of smaller groups will probe at the roots of other physics mysteries with experiments that will study the insides of protons, probe the behavior of cosmic rays, and search for the long theorized magnetic monopole, a hypothetical particle that is an isolated magnet with only one magnetic pole. Now, adding to these are two new experiments called Phaser, Forward Search Experiment, and SND, Scattered Neutrino Detector, that were made possible by the installation of two new detectors during the accelerator's recent shutdown. Phaser will scan for extremely light and weakly interacting particles, such as neutrinos and dark matter, and SND will exclusively search for neutrinos, ghostly particles which can travel through most matter without interacting with it. One, particle physicists are particularly, once they're excited to look for this long sought after axion, a bizarre hypothetical particle that does not exist, absorb or reflect light, and is a key suspect for what dark matter is made up of. This third run of the LHC is slated to last 4 years. After that time, collisions will be halted once more for further upgrades that will push the LHC to even greater levels of power. Once it has been upgraded and begins running again in 2029, the high luminosity LHC is expected to capture 10 times the data of previous 3 runs combined. This is by Ben Turner on Live Science. Please leave your comments. Thank you for your support. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.